All right, Math 115 students, let's take a look at your pretest. Hopefully you had a chance to take a look at it, try some things, get some answers. What I'm going to show you in this video is not only the answers, but the way that I would like to see you come up with the answers. My math, I'm not going to be using any calculator, so no technology is involved. I'll try to explain myself and what I'm doing in each case. Especially with fractions, you need to show your work. You need to have a very good understanding of what you're doing and why, because in the future we're going to be dealing with fractions in a lot of other different situations, and if all you know how to do are tricks, those tricks aren't going to work. Alright, so you really need to know what's going on. On that note, as I work through the pretest, and you do your homework on my math lab, if you're struggling doing any of these problems, understanding how to do them, then please make sure that you drop back to another class. I highly recommend that. No use suffering through a class if you don't have the bare essentials. Alright, so without further ado, here's basically your answer key. And for this page, if you need more practice after watching me do things, you're looking at section 1.3 in my math lab. Alright, and so here we go. So for starters, I'm asking you to find the prime factorization of 70. Well, breaking this down, when I talk about factorization, I'm talking about breaking a number into a product. So when I look at 70, right, perhaps, we got 2 times 35. Some of you guys are probably thinking 5 times 14, and then maybe you're even thinking 7 times 9. So each one of these is a factorization of 70. I'm breaking down the number into a product of its factors. However, I want the prime factorization. So what that means is we have to go a step further. 2, when we look at it, is a prime number. So that one's good to go, but 35 still breaks down. So this breaks down into 2 times 5 times 7. And you'll notice at this time, all the factors are prime numbers. They don't break down anymore. So we have the prime factorization of 70. What's nice about prime factorization, it doesn't matter how you start, we all end up with the same 3 prime factors. So over here, 5 is already prime, and 14 breaks down into 2 times 7. So a different arrangement, but the same 3 numbers. 7 times 10, well, 7 is prime, and 10 is 2 times 5. So it doesn't matter how you start, but when you're giving the prime factorization, you end up with the same, in this case, 3 prime factors of 70. So 70, no matter how you break it down, its prime factorization is 2 times 5 times 7. That's prime factorization. Part 2, what I'm asking us to do is I want us to simplify a fraction. Now, to simplify a fraction basically means that we're trying to reduce it so that the fraction is equivalent. It's the same number, but the numbers aren't as large, I guess you can say. It's just a different reflection of that number. So there's a lot of little magic tricks, but what I'm specifically asking for is the prime factorization. So we're going to need to use that because in the nuts and bolts of it, we're trying to find factors that are the same. And I think a lot of you can already see that 7 is a common factor. And so we can divide out that 7 and go on. But again, I'm asking for prime factorization. So this is how this works. This is how I find the common factors. I start by taking 28 and breaking it to its prime factors. So that's 4 times 7. And breaking that further, that's 2 times 2 times 7. So there's the prime factorization of 28. Of course, from the work above, we already have the prime factorization of 70. So that means I can come over to my fraction and I can break that up, right? 28 is 2 times 2 times 7. That's its prime factorization. And 70 is 2 times 5 times 7. And so we can start to see this idea of 1, right? So 2 divided by 2 is 1, so it divides itself out. And 7 divided by 7 is 1, so it divides itself out. And what we're left with is the fraction 2 over 5. I'm done simplifying this fraction because 2 and 5 are what we call relatively prime. They don't share any common factors amongst each other. And the idea here is that this fraction here is equivalent to that simplified fraction there. As a matter of fact, if you wanted to, break out your calculators, and you'll notice that this is 0.4, and this is also 0.4, right? Showing you that these two fractions are the same, but this fraction is a little easier to work with. Last but not least, if we were to write a picture for this, this would basically take a whole piece, break it up into 5 equal parts, and use 2 of them. So there's a picture of 2/5. 28 over 70 would take that same whole part, but this time we're breaking things up into 70ths. So that would be quite the task to break it up into 70 pieces, but that 28 says to use 2 of them. And so you'll notice, kind of hard to see, it's not to scale, but the picture of 2/5 is the same as the picture 28 over 70. So what we have here are equivalent fractions. Same number, same pieces, but very different stories behind them. Equivalent fractions. And that's basically the heart and soul of simplifying a fraction, and I use my prime factorization to help me accomplish that goal. Alrighty? So hopefully that's some pretty good review of a lot of different ideas. Okay? So going down into some operations, what I'm asking us to do here is to basically subtract a couple of fractions. And so what I'm going to do is first rewrite 3 as 3 over 1. Alright, so I can see it as truly the subtraction of fractions. In order to subtract or add fractions, I need an LCD. So in this case, it is 5. 5 goes in itself once, and 1 goes into 5 times. So it's the common denominator, the lowest one. And what I need is this idea of equivalent fractions again. So this fraction already has 5, but 3 over 1, I would need to multiply by 5 over 5. This builds an equivalent fraction. It's that idea of 1. 5 over 5 is 1, and anything times 1 is itself. Now this is obviously going to give us another fraction, but I think you guys would agree with me, right? 15 over 5 is the same thing as 3. And as a matter of fact, we just multiply, right? Multiplication is top to top, bottom to bottom. So 15 over 3. So when I subtract now, we keep that denominator and we subtract the numerators. So in this case, we get 13 over 5. That improper fraction is an acceptable answer. Of course, if you wanted to, you can break that up into 2 and 3/5 as well. I would accept either one, but either one's fine. But the idea is subtraction. We need a common denominator. You need to multiply by some form of 1 to create an equivalent fraction. And then to actually perform the subtraction, you keep the denominator. And then in this case, you subtract your numerator, excuse me. So same thing here with addition. It's the same idea. We need an LCD. So what number does 9 divide into and 12 divides into? The lowest one? Well, that would be 36. So for the 9, I would need to multiply by 4 over 4. Again, that's 1. Plus 1 over 12, well, I would need 3 over 3. And so we'd end up with 20 over 36 plus 3 over 36. And we're back to that idea of an equivalent fraction. When you say 5/9, that's the same thing as saying 20 over 36. When you say 1/12, that's the same thing as saying 3 over 36. And the reason being is because of that multiplication by 1 we used there. 4 over 4 and 3 over 3 respectively. Now that I have the same denominator, I keep it. And in this case, I add up my numerators, and we end up with the answer of 23 over 36. All right, and so there's hopefully a really good beginning. This idea of prime factorization, this idea of using prime factorization to simplify, the idea of equivalent fractions, what that means, and then using them to actually perform my adding and subtracting of fractions. We're already about 9 minutes into this video, so why don't I cut this short, and we'll do C, D, E, and F in the next video outtake. All right, thank you for your time. Hopefully this is a good review. Again, to practice more, you're going to be going into section 1.3 in my math lab.